So I'm going to repeat the title because that's how I've practiced. And you already introduced me, but I have to reintroduce myself because that's how I practice. My name is Felipe Piedra. I'm a postdoc at Baylor College of Medicine in the lab of Piedra. And today I'm going to talk about the interdependencies of viral load, the innate immune response, and clinical outcome in children presenting to the ED with RSV-associated bronchiolitis. So I'm going to start with something everyone knows. I've depicted a typical rectangular human host, and when RSV enters, it immediately starts to consume host resources and interfere with host processes to initiate disease, or to replicate and thereby initiate disease. And the host responds in turn to limit viral replication and can thereby intensify disease in the short term, but ideally only to destroy RSV and end disease in the longer term. And my point is simple. Is this one working? Okay. So my point is simple, and that is that disease is a relationship between host and pathogen, and pathogen and host. And if you want to understand the mechanisms of disease, then you have to consider both pathogen and host. So in the following study, we sought to better understand the viral and host determinants of severe RSV disease in otherwise healthy infants. Now, what do I point at? Oh, okay. So our approach was simple. We collected nasal wash samples from a large number of infants who presented to the emergency department with RSV-associated bronchiolitis, and all infants were a subgroup of, the infants were a subgroup of all infants enrolled in one of the lab's most recently published studies, Nicholson et al. 2016. And, oh, damn it. Oh. What happened? Oh, okay, sorry. So then I measured viral load and gene expression by measuring the abundances of NS1, NS2, and GNF genes by qPCR in each sample. And I also measured RNase P copy number, and RNase P is a host housekeeping gene to determine sample quality and for data normalization. And we also measured the host innate immune response by measuring levels of a diversity of cytokines. And finally, we asked what relationships can we detect between host and viral variables that we've measured, and does either relate to clinical outcome? Clinical outcome being measured by whether the kids were hospitalized or sent home shortly after being admitted to the emergency department, and also being measured by O2 saturation levels. And I want to add that our samples were collected early in the course of illness, so 73% of them were collected from infants who had been sick for less than 5 days. And before jumping into our more interesting results, I want to quickly tell you that there were no significant differences in demographic and patient history variables based on clinical outcome among the infants whose samples were used in this study. So the first thing we asked was, do the RSV gene copy numbers I measured correlate with levels of cytokines that were shown in the lab's previously published study, Nicholson et al. 2016, to associate with improved clinical outcome? And each box in the table has a Spearman correlation coefficient, and in parentheses, a p-value for the relevant RSV gene copy number and cytokine pair. And I'm showing unnormalized data. And when you look at unnormalized data, you can see that there's strong correlations between levels of IP10 and every RSV gene copy number measured. And when we normalize the data, so we divide RSV gene copy numbers and cytokine concentrations by RNase P copy numbers, just about everything becomes significantly correlated. So it's interesting because the cytokines, again, were shown in a previous study to associate with clinical outcomes. So the next thing we asked was, are there differences in RSV gene copy numbers between infants who are more or less sick? And now in this table I'm showing you, each box has a median value and in parentheses interquartile range for the relevant RSV gene copy number for both raw and normalized data for kids who were sent home and kids who were hospitalized shortly after being admitted to the emergency department. And by Wilcoxon-Mann-Whitney test, there's a significant difference between NS1 copy numbers and RNSP normalized NS1, NS2, and NG gene copy numbers between kids who were sent home and kids who were hospitalized. And in all cases, the RSV gene copy number, the median RSV gene copy number is about 5-fold bigger in kids who were sent home. So there's more virus, apparently, in kids who are better off. So to sort of further probe that correlation, we look for correlations between RSV gene copy numbers and O2 saturation levels. Because if it's indeed the case that kids with more RSV gene copy numbers are better off, then you would expect a positive correlation between RSV gene copy numbers and O2 saturation levels. And that's exactly what we see for RNSP normalized NS1, NS2, and N genes. So the next thing we did was turn to multivariate analyses to get a better idea of the determinants of disease severity in our patient cohort. And we used disposition as outcome, disposition from the emergency department, whether the kids were hospitalized or not, and the following independent variables: age of the child, duration of illness, virus type, whether it's RSV A or B, normalized copy numbers, and certain normalized cytokine biomarker levels. And we tested each normalized copy number separately and got the following associations. So IP10 associates with less severe disease, and LDH weakly associates with more severe disease. But the very interesting thing is that although we observe correlations between RSV gene copy number and disease severity, there's no association when we use this more rigorous statistical test between RSV gene copy numbers and clinical outcome. And so the point is that the apparent protective effect of RSV has to be indirect. RSV can only protect to the extent that it elicits a productive host response. And finally, to conclude, I'll just repeat that our major observation was that viral loads in this case, in this patient population, were higher among otherwise healthy infants with RSV-associated bronchiolitis who ultimately experienced less severe disease. And it could be that higher viral loads early in illness just favor a rapid and productive host response by increasing the likelihood of early detection. It might also involve the viral load-dependent formation of defective viral genomes. So it's known in vitro cell culture, for instance, that if you grow a virus up, starting at high MOIs, you do generate these defective viral particles. And it's been shown recently that they're potent stimulators of the innate immune response, but of course they can't do anything to sort of help the virus get along. And finally, I would say that the main hypothesis to emerge from this study is that the timescale of the host response in otherwise healthy infants is crucial to determining disease severity. And some limitations in the study are that the infants involved experienced a rather narrow range of disease severity. They all had lower respiratory tract illness. We also have single time point data. So the claim is not that infants who shed more virus over time are less sick, only that early in illness, there's a possibility that more virus means that you're less likely to experience severe disease. And in the future, we want to confirm these results and test our conclusions in additional clinical studies. And I'm measuring copy numbers in multi-time point data now. So, yeah, and thank you.
That was very interesting. But you make us life more complicated because if we thought we have it confused when we measure one or two genes, if we measure the NS1, the NS2, it shows that the dynamics are very different. There is an important paper from the Piedra lab with more than 1,000 patients that really, with the cohort, the Camargo cohort and Mansbach cohort, that really showed that the number of genomic copies correlate with disease severity, right?
Yeah. So in that, I should
please
allow you to finish. So in that case, and feel free to step in, boss, if you wish. So in that case, of course, no attempt was made to correct for sample quality. We're also using different measures aside from that. In that paper, they used CTs to determine a genomic load. And they sort of set thresholds called it low genomic load, moderate genomic load, and high genomic load, and saw an association there. But in this case, we're using copy numbers. And it's a different beast. This is, CTs are equal to the amplification efficiency of your target times the logarithm of the copy number. So I think that's important.
So the question is, you think by measuring the peak or the top versus, obviously you only have one time point, right? Or, I mean, we need to transform this into area under the curve type of total production of viral. And can you, with the data that you have, adjust? I know that you showed, I mean, you present so much data. Can you correct or adjust for time of duration and age together? I mean, how much of this age and time of duration can be affect your findings?
Yeah. So in the multivariate analyses, age and duration of illness, I guess, were not significantly associated with disease severity. But, dumb answer to your question too. There's no retrieving viral load through time data, right? We do need more samples. Nevertheless, I think the argument that more virus early in infection might dispose the host toward ultimately less severe disease is interesting. But yeah, it would be ideal to have all the measures that we want, right?
Finally, sorry.
No.
NS1, before you do that correction, look like very different than the others, right? When you look at NS1 has the better differentiation between the patients who were hospitalized and those who were sent home. Why?
So NS1 in the raw data, and I don't know. No, I don't know.
Rod Smith, University College London. So a very simple question. The differences between your children that were sent home and those that were hospitalized, could that be accounted for by how long they'd experienced their illness? It wasn't clear from your presentation.
No, so I'm not sure. Maybe I went through that first slide too quickly. I'm not sure that I included it. Is there any way I can go back? So duration of illness, as I recall, was not significantly different between kids who were hospitalized and kids who were sent home.
Jürgen Schwarzer, Edinburgh. I guess my question is very closely related to what you just initially discussed with Ottavio. You talk about increased viral load. This is all based on genetic data, is it?
Yeah.
So you don't have viral titers?
No.
Because I think the central question for me is NS1 being very early in the genome, maybe transcribed to very high levels, and may actually not correlate with live viral titers.
So in this case, actually, and perhaps it would have been important to show these data, but all of the copy numbers correlate with each other and linearly. And NS1 actually is not the most abundant. G is. Again, it would be ideal to have a measure of viral load that would be something like plaque forming units per mil, but we don't have it. No.
Kate O'Brien from Johns Hopkins. Thank you for a beautiful presentation. We're very pleased you practiced it also beforehand. That was lovely. The question I have is, we've heard throughout the past couple of days about pathogen interactions. And what consideration have you given that those who are more ill have a co-pathogen there that also relates to the inability for RSV to proliferate more rapidly?
Yeah.
And so you've actually got a confounder there with respect to co-pathogens or co-infections. Thank you.
Thanks. So in this case, Boss, again, correct me if I'm wrong, but I'm fairly certain that we only analyzed samples that tested positive for RSV. So we did look for, in a previous study, they looked for other viral pathogens. I'm not sure that we can say anything about whether the children had bacterial infections, but I at least know that I'm fairly certain that all the samples were only positive for RSV.
One last quick question.
Holland from Australia. A long time ago, before PCR was invented, there was papers that came out that showed that the viral load, based on, I think, on sections of lung from post-mortem specimens, I think, that the viral load was different in children who had predominantly wheezing stroke bronchiolitis type of illness, as opposed to children who had predominantly a pneumonia type of illness, with the former having less viral load than the latter. These are old studies. I haven't heard anything about that recently, but is there any new information along those lines? Were there differences in clinical presentation like that between the high and low viral load group?
I don't know. So, I have a poster as well. I think you and I should look at the demographic and patient history table, and the same table has physiologic variables based on clinical outcome. So, it's a bad answer, but I don't know.